All right, for lesson 7.7, we are dealing with area and mixed numbers. Our essential question is, how can you use a unit tile to find the area of a rectangle with fractional side lengths? When they say fractional side lengths, they mean that the length of one side of the rectangle is not going to be a whole number. It's going to end up being a mixed number. So it's going to have a whole number and a fraction. So let's take a look at the first example. It says, Sonia wants to cover the rectangular floor of her closet with tile. The floor is 2.5 feet by 3.5 feet. So there's our mixed numbers. She wants to use the fewest tiles possible and does not want to cut any tiles. The tiles come in 3 sizes: 1 foot by 1 foot, 1/2 foot by 1/2 foot, and 1/4 foot by 1/4 foot. Choose the tile that Sonia should use. What is the area of the closet floor? Okay, so then we've got some steps to work through. So here, as I read them in the problem I was pointing to, they've drawn out for us. Here's a tile that's 1 foot by 1 foot. Here's a tile that's 1/2 foot by 1/2 foot. And here's a tile that's 1/4 foot by 1/4 foot. Okay, and you can tell because they've written the measurement right by the side. So that tells us how long that side is. Okay, so it says choose the largest tile that Sonia can use to tile the floor of the closet and avoid gaps or overlaps. Okay, so she doesn't want spaces between her tiles and she doesn't want 2 laying over top of each other. Okay, she wants them right next to each other. So I know I'm working with 2.5 feet and 3.5 feet. So a 1 foot by 1 foot tile isn't going to work, right? If I'm trying to lay tile down in a length of 2.5 feet and each one is 2 feet, or is 1 foot, I would lay 1, I would lay another, that would give me 2 feet. But if I laid another one, that would give me 3 feet. So if I lay 3, I'm over, and she would have to cut it. And if I laid 2, then she wouldn't have enough. She would have a gap. And the problem told us she didn't want that. So we know that the 1 foot by 1 foot is not going to be the right size. Now if I take a look at the 1/2 foot by 1/2 foot, I know I'm dealing with 1/2 feet, right? 2.5 feet, 3.5 feet. So that would make up that difference. And I know that 1/2 plus 1/2 is 1 whole. So if I laid 2 of these next to each other, I'm going to get 1 foot. If I laid down 2 more, I'm going to get 2 feet. And then if I laid down 1 more, I'm going to get 2.5 feet. So I know that would work. And it would work with 3.5 as well. I would just have to lay down 2 more to get that extra foot. So the 1/2 by 1/2 is going to be the largest tile that she can choose. Okay, so 1/2 foot by 1/2 foot. And it is because of what I just said. If she lays them down 1 by 1, 2 of these equal a foot, 4 of them equal 2 feet, and then 1 more equals the 1/2. And then on the other side, 2 equal 1 foot, 2 more equal 2 feet, 2 more equal 3 feet, and then another one would equal the 1/2. Okay, so I'm not going to take time writing that down, but that is the explanation of why we would choose 1/2 by 1/2 as the largest. Okay. So, knowing that this is the size tile I'm going to be using, B says on the grid, let each square represent the dimensions of the tile you choose. Draw the diagram of the floor. Okay, now remember my floor is 2.5 by 3.5. So now you're going to see what I've been saying. So one of these this way is going to equal 1/2 of a foot. One of them this way is going to equal 1/2 of a foot. Okay? So if I'm starting with 2.5 feet, well, here's half a foot. That makes 1 foot. That makes 1.5 feet. That makes 2 feet. That makes 2.5 feet. Okay, so I know that that's where the corners of her closet are going to be. And I'm going to write over here, this side is 2.5 feet. Okay, so now I'm going to do the same thing for the length of her closet, which is 3.5 feet. So here's half a foot, 1 foot, 1.5 feet, 2 feet, 2.5, 3 feet, and 3.5 feet. So there's the other corner of her closet. And this side is showing me 3.5 feet. And it told me it was a rectangle, so I just need to draw my lines to make it look like a rectangle. It means opposite sides are going to be the same length. Okay? So there's my diagram. There's B. Then for C, it says count the squares in your diagram. How many squares cover the diagram? We could sit here and count all of them inside this rectangle. Or we could multiply. I could multiply how many are going down and how many are going across, and that will tell me how many are in here. Okay, so I have 1, 2, 3, 4, 5 squares going down. 1, 2, 3, 4, 5, 6, 7 squares going across. And 5 times 7 is 35. So if I counted all of these squares, I would get 35 squares. Okay? So then it says, what is the area of the tile you chose? Okay, so to find the area of the tile we chose, area equals length times width. And when they do the formula using length, they always do a cursive L. That way if you write like a print L, you don't mistake it for a number 1. Okay, so area is length times width. So if we chose the tile that was 1/2 foot by 1/2 foot, the area of the tile would be 1/2 times 1/2, which 1 times 1 is 1, 2 times 2 is 4. So it would be 1/4 square feet, or square foot, I'm sorry, because it is not greater than 1. Okay, so this is the area of one tile. Okay, so you want to make sure you are not confusing when it's asking for the area, that you're not confusing that with the length of one side. Okay, remember, to find area, you have to do length times width. That's what's going to give you the area. So if it's asking for area, you have to multiply the length of both sides together. Okay? So then it says, since one square on your diagram represents the area of 1/4 of a square foot, the area represented by the total number of squares we have, which was 35, is, right, if we want to find that total, it's going to be 35 times the 1/4, because remember, we're finding area. Okay, and then of course when we multiply this out, we would have 35 over 1, remember a whole number can be written as a fraction, put over 1, times 1/4, 35 times 1 is 35, 1 times 4 is 4, okay, so it would be 35 fourths. square feet. Okay? So the area of the floor then written as a mixed number, if I wanted to convert this to a mixed number, I think how many times does 4 go into 35 without going over? Well, it goes in 8 times, because 8 times 4 is 32. Then I would do 35 minus the 32 that I've pulled out, which leaves me 3/4. Okay, so written as a mixed number, it is 8 3/4 square feet. All right, now you may be saying to yourself at this point, well, I could have used the 1/4 by 1/4 size tile, which is true, it would fit. And I'm going to show you why we wouldn't choose that one in just a second. If we go back to our problem, remember here in that third sentence it says she wants to use the fewest tiles possible without making any cuts. Okay? We can tell visually that this tile is smaller than this tile. Okay? So if it's smaller, it's going to take more of them to fill in this area than it is to use this size tile, the 1/2 foot by 1/2 foot. Okay, let me show you that. Move this out of the way. All right, this black piece of paper right here, let me zoom out so you can see the whole thing. This black piece of paper is 1 foot by 1 foot. Okay, I've measured it out. 1 foot is 12 inches, so it's 12 inches across both ways. It's 1 foot by 1 foot. So that largest tile that she had to choose from would be this size. Okay? And it says the second tile was 1/2 foot by 1/2 foot. Now, I know that 1 foot is 12 inches, so 1/2 foot is going to be 6 inches, right? It's going to be half of that. So if, I'm just going to show you real quick. Okay, so I'm going to cut this in half this way. And then I'm going to cut it in half this way. Essentially, I am now making 1 foot or 1/2 foot by 1/2 foot or 1/2 foot by 1/2 foot tiles. Okay, so if the whole tile is 1 foot by 1 foot, each of these is now 1/2 foot by 1/2 foot. Okay, so it would take 1, 2, 3, 4 of these 1/2 foot by 1/2 foot tiles to cover the same amount of floor. Okay, but we already know that the 1 foot tile was too big. It was not going to work because she would have to cut it. Now let me flip it over. So we still have that same size tile. A little hard to see on the black table, but it's here. 1 foot by 1 foot, 1 foot by 1 foot. Okay, still that same size square. Now, if she had chosen the 1/4 by 1/4 foot, or 1/4 by 1/4, I'm going to show you how many of those tiles it would take. Okay, just to kind of visualize how they are smaller and how many you would need. Okay, now keeping in mind again, 1 foot is 12 inches. If I was going to divide 1 foot into fourths, each little square, each tile would be 3 inches across. Okay, so let me show you that. So there's 3 inches, 3 inches, 3 inches, and then 3 inches would take us to the end. Let me draw these out real quick. Not perfectly straight, but close enough to get the idea. do it the other direction. Same thing, we're dealing with a foot. So to make it 1/4 inch or 1/4 foot tiles, they would each be 3 inches by 3 inches. Okay, so now I have drawn out one side of this is 1/4 of a foot, and this side is 1/4 of a foot, right? Because I have 1, 2, 3, 4, and I know that this makes 1 foot, and I have 1, 2, 3, 4, and I know that this makes 1 foot, okay? So if she had chosen the 1/4 foot by 1/4 foot tile to cover the same amount of floor, it would have taken her 16 tiles. So she chose the 1/2 foot by 1/2 foot, it would have only taken her 4 tiles to cover the same amount of floor. Okay, I hope that makes sense in understanding where both the 1/4 and the 1/2 would work. She wouldn't have to cut anything, she wouldn't have any gaps, she wouldn't have any overlapping. But remember, the question asked which one is the fewest tiles that she would use. It would be the 1/2, because one of those tiles takes up more space. Okay? So that's how you would do that first example. All right, so on the next page, we've got our draw conclusion section. So it says, write a number sentence for the area of the floor using fractions greater than 1. Now remember, a fraction greater than 1 means the numerator is larger than the denominator. So explain how you knew which operation to use in the number sentence. Okay, so let's flip back for a second, because we're dealing with our numbers from over here. So if our tile that we chose to use was 1/2 of an inch by 1/2 of it, or I'm sorry, 1/2 of a foot by 1/2 of a foot, we need to find out how many of these tiles are on each side. So going lengthwise, we have 1, 2, 3, 4, 5, 6, 7. And going down or widthwise, 1, 2, 3, 4, 5. So as we were laying these tiles, we would lay 7 tiles across, and we would make 5 rows of those 7 tiles. Okay? So that means that this, the 7 across, can be written as 7/2, because that means we have 7 1/2 tiles. Okay? And just like we said on the other side, I'll write it over here again, area equals length times width. Okay? So my function is multiplication. And then the other side, we said there were 5 going down, or the width was 5, so it would be 5/2, or 5 1/2-foot tiles. Okay? And we knew from our formula we're finding area, or I mean that we're multiplying based on our formula, okay? Because we're multiplying the top across what's going down. All right? So then it says, explain how using fractions greater than 1 can help you multiply mixed numbers. Well, how it's going to help us is if we change the mixed number, which this one as a mixed number would have been 7 tiles times 1/2 of a foot. the 5/2 is 5 tiles times 1/2 of a foot. Okay? So instead of using those mixed numbers of the 5.5, right? If we use the fractions greater than 1, then we can just multiply straight across. Okay, so by using, oops, not mixed numbers, by using fractions greater than 1, we can multiply our numerator, then our denominator. Okay, just like we learned before how to multiply fractions. Multiply your numerators, multiply your denominators. So if we are using the fractions greater than 1, we can just do that straight across. Okay? So then it asks us, how many 1/4 foot by 1/4 foot tiles would Sonia need to cover her 1/2 foot by 1/2 foot tile? So let me pull this back over. Okay, so here's our one tile of 1/2 by 1/2 foot. Okay, I'm going to cut out just this one tile, my 1/2 by 1/2 foot tile. Okay, that's how big this tile would be. Now remember, we drew 1/4 foot tiles on the other side. So if I flip this over, I'm going to see how many 1/4 foot tiles, 1/4 by 1/4 foot tiles, fit inside this. Okay, so we have 4. 1, 2, 3, 4. So 4 1/4 foot tiles will fit inside a 1/2 by 1/2 foot tile. Okay, so we have 4 tiles will fit inside there. All right. So it says, how could you find the number of 1/4 by 1/4 foot tiles needed to cover the same closet floor? Okay, so we're going back to that closet floor that had the 35 squares, where we said each square was 1/2 foot by 1/2 foot. How could we find out how many tiles it would take if we had chosen the 1/4 by 1/4? Okay. Well, we could multiply those 35 squares by 1/4 tiles. Okay. Since 4 of these little 1/4 ones equals this. Okay. So we could multiply 35 1/4 foot tiles by 4 since we know that 4 1/4 foot by 1/4 foot tiles makes, well, I shouldn't say makes, we'll say fills a 1/2 foot by 1/2 foot tile. Kind of running out of room. Okay, so basically we know that inside this 1/2 foot tile I'm going to have 4 1/4 foot tiles. Okay, And if I know that 4 of these, the blue one, the big blue one, takes to fill that floor, then I know 4 inside those 4 is essentially what you're doing. Okay? So it would be 4 times 4. It would take 16 1/4 by 1/4 foot tiles to fill that floor. Okay, so that obviously wouldn't be the fewer. If it only takes 4 of the big blue ones, it would take 16 of the little blue ones. Okay. Then we have, sometimes it's easier to multiply mixed numbers if you break them apart into whole numbers and fractions. Okay, so we're going to use an area model to solve 1 3/5 times 2 3/4. So the first step to doing this is rewriting each mixed number as the sum of the whole number and the fraction. Okay, so this would be 1 plus 3/5, and this would be 2 plus 3/4. Okay. Step 2 says draw an area model to show the original multiplication problem. Now to do this, we're going to use a rectangle. Okay, we're dealing with area, so we know it's going to be length times width. So one side is going to be 1 3/5. The other side is going to be 2 3/4. Right? And if we multiply those two together, then we get the area. So this is the model for the original multiplication problem. Let me zoom in just a little bit. Okay. Step 3 says draw dashed lines and label each section to show how you could break apart the mixed numbers that we did in step 1. Okay. So I'm going to draw a second one just so we don't get confused. Okay. Now, remember this is 1 3/5. So I'm going to draw a dotted line. Obviously the 1 is going to be bigger. Draw it dark enough. There we go. So this represents the 1 from here to here. This part represents the 3/5. Okay, I'm going to do the same thing going across. I had 2 3/4. So from here to here, it represents the 2. From here to here, it represents the 3/4. Okay. Then it says find the area of each section. So now we have 4 sections in here. So we're going to find the area, length times width. So we have 1 times 2. This one is going to be 1 times 3/4. Right at an angle. 1 times 3/4, which equals 3/4. This is going to be 3/5 times 2. 3/5 times 2, which equals 6/5. And then this one is going to be 3/5 times 3/4. 3/5 times 3/4, which equals 9/20. It didn't all fit in the box, but that all goes in this box right here. Okay, so you guys see how I did that? I just multiplied the width of this by the length of this, the width of this by the length of this, the width of this by the length of this, the width of this by the length of this. Okay, so we're just multiplying all those together. Then step 5 says we can add the areas of each of these sections together to find the total area. Okay, so I'm going to circle the areas of each section, and then we can add those together. So we had 2 plus 3/4 plus 6/5 plus 9/20. And if we add all those together, of course finding common denominators, because our denominators have to be the same when we add, we would get 88/20. Or if we changed it into a mixed number, it would be 4 2/5. Okay? So that means the product of 1 1/3, remember our original problem, times 2 2/3, or I'm sorry, 3/4, is 4 2/5. Okay, so this is just another way to multiply those if you do not want to change them into mixed numbers. Okay? All right, so that is your lesson for today.